This is the Internet Court of Truth and Lies. Its purpose is if you have something that you think is the truth or you think is a lie in the media, then you can take that to up to 8 people and basically make your presentation, dissect what you think is the truth or a lie, and then see how they dissect it using a standard set of 8 verdict questions. The 8 verdict questions are never perfect for anything, but by having a uniform set of 8 verdict questions, they allow you to really guide the discussion based on the fundamental elements of truths and lies. So this discussion tends to stay on truths and lies. Today, we're going to do what I think is a very interesting thing. I'm a computational cognitive neuroscientist, and I've been studying human lying for about 10 years now. I call it mendaciontology. One of the things that when you're studying human lying, where you're really defining a lie as something that anybody will call a lie. People use lots of definitions for lies, but we use a behavioral definition, which is anytime someone calls something a lie, or they can call it a lie and you understand what they're saying, then it's a lie. That's what we study. One of the interesting things is asking the question, who are the best liars in the world? One argument is the argument I'm making today, which is that physicists are the best liars. I'll bring up a little bit of the case here.
Physicists are the best liars, the pinnacle of humankind. The study of lies, mendaciontology, is a computational cognitive neuroscience. No group of people have succeeded so well at lying than the physicists.
One of the things is to try to understand what physicists lie about. What is it to be a physicist? Recently, there has been an extremely good discussion of physics as a discipline of discourse, a way of talking to other people. I'm going to play a little bit of that. A lot of y'all may well find for the first time you understand what physicists do, because whoever did this video really nailed it. Here we go.
Where almost no one has ever been. Not into space, not to another galaxy. We're going inward, deep inside the fabric of matter itself, because right now, buried beneath everything you touch, everything you are, there appears to be a hidden layer. A structure beneath the structure, and the experiments happening at CERN, where particles are smashed together at nearly the speed of light, are beginning to pull back the curtain on something that could reshape our entire understanding of reality. The measurements are coming in. Some of them match what physicists predicted, and some of them do not. And those mismatches, those tiny cracks in our most successful theory, may be the first glimpse of something we have never seen before. Before we go any further...
By the way, the tiny cracks are what I would argue are lies, because they didn't get it right.
Further, let's begin. Let us start with something you already know. Matter. The stuff of the world. The chair you're sitting on. The phone in your hand. The air filling your lungs right now. Your body itself. All of it is matter. And for most of human history, we had absolutely no idea what matter actually was. We could describe it. We could shape it and melt it and burn it and build things out of it. But the question of what it is made of, what it truly is at the deepest level, remained a mystery for thousands of years. And that mystery turned out to be far deeper and far stranger than anyone imagined. The first person we know of who seriously proposed an answer was a Greek philosopher named Democritus, who lived...
And of course, my argument is democracy, if that doesn't look like a liar, I don't know what does.
Lived around 460 years before the Common Era. Democritus suggested that if you kept cutting matter into smaller and smaller pieces, eventually you would reach something that could not be cut any further. He called these pieces atomos, which in Greek means uncuttable. It was a brilliant idea. Simple, elegant, and logical. If you break a rock in half, you get 2 smaller rocks. Break those in half, you get 4 even smaller pieces. Keep going. At some point, Democritus reasoned, you must reach a piece so small that it cannot be divided any further. That would be the fundamental building block of everything. It was also completely untestable at the time. Democritus had no microscope, no laboratory, no way to verify his hypothesis. It was pure philosophical reasoning. And because of that, it was largely set aside for over 2,000 years. Aristotle, whose ideas dominated Western thought for centuries, rejected atomism in favor of a theory that all matter was made of 4 elements: earth, water.
By the way, in the URL for the case that reads the case, I put the link to this video.
These elements could transform into one another, mix in different proportions, and combine to create the variety of substances we observe in the world around us. It was wrong, but it was the dominant view for an extraordinarily long time. Entire civilizations rose and fell while people still believed that everything was made of 4 basic elements. Alchemists spent centuries trying to transform lead into gold based on this mistaken framework. It was not until the scientific revolution that humanity began to seriously question these ancient assumptions and develop the tools to test them. The idea of atoms did not become a serious scientific proposal until the early 1800s, when an English chemist named John Dalton revived it. Dalton noticed something remarkable about chemical reactions. Elements always combined in fixed, predictable ratios. Hydrogen and oxygen always combined in a specific proportion to make water. Carbon and oxygen always combined in a specific proportion to make carbon dioxide. No matter how many times you ran the experiment, the ratios were always the same. This made perfect sense if elements were composed of tiny indivisible particles, each with a specific mass. Different elements had particles of different masses, and chemical reactions were simply rearrangements of these particles into new configurations. Dalton's atomic theory was one of the great leaps in scientific understanding. It took Democritus's ancient philosophical speculation and turned it into a testable, predictive framework that could explain the patterns chemists were observing in their laboratories every day. But here is where the story starts to get truly interesting, because atoms turned out not to be uncuttable after all. In 1897, a British physicist named Joseph John Thomson discovered the electron. He was experimenting with cathode rays, streams of particles produced inside vacuum tubes when an electric current was passed through them. Thomson found that these rays were made of incredibly tiny particles carrying a negative electric charge. These particles were much, much smaller than any atom. They came from inside atoms. This was a shock to the scientific community. If atoms contained smaller particles within them, then atoms were not fundamental. They had internal structure. They could be taken apart. The thing that was supposed to be uncuttable could, in fact, be cut. Thomson proposed a model of the atom that became known as the plum pudding model. He imagined the atom as a uniform sphere of positive charge with negatively charged electrons embedded throughout it, like plums scattered through a pudding. It was a reasonable guess given what he knew at the time. The atom had to be electrically neutral overall, since matter is normally uncharged. So the negative electrons had to be balanced by something positive. Thomson imagined that positive charge spread smoothly throughout the atom. But he was wrong. In 1911, a New Zealand-born physicist named Ernest Rutherford performed one of the most famous experiments in the history of science. Working at the University of Manchester with his assistants Hans Geiger and Ernest Marsden, he directed a beam of alpha particles, which are essentially helium nuclei carrying a positive charge, at a thin sheet of gold foil only a few hundred atoms thick. If Thomson's plum pudding model was correct, the alpha particles should have passed through the foil with only slight deflections. The positive charge in the atom was supposed to be spread out, so there would be nothing dense enough to deflect the alpha particles significantly. Most of the alpha particles did pass straight through the foil as if it were not even there. But a tiny fraction of them, roughly 1 in 8,000, bounced back at large angles, and a few even bounced almost straight back toward the source. Rutherford was stunned. He later said it was as remarkable as if you had fired a 15-inch artillery shell at a piece of tissue paper and it came back and hit you. The only way to explain this result was if the positive charge and nearly all the mass of the atom were concentrated in an incredibly tiny, dense core at the CEU center. Rutherford had discovered the atomic nucleus. The nucleus is extraordinarily small compared to the atom it sits inside. If you scaled an atom up to the size of a football stadium, the nucleus would be about the size of a marble sitting at the center of the field. Everything else, all the vast space between the nucleus and the orbiting electrons, is empty. This means that atoms, and by extension all matter, are almost entirely empty space. The solid feel of the table beneath your hands, the hardness of a rock, the firmness of the ground beneath your feet, none of it comes from actual solid material packed tightly together. It comes from electromagnetic forces between atoms, forces that resist compression and give the illusion of solidity. But at the atomic level, what you think of as solid matter is overwhelmingly nothing at all. The nucleus itself turned out to contain two types of particles: protons, which carry a positive electric charge, and neutrons, which carry no electric charge. Protons were identified by Rutherford in 1919 when he demonstrated that hydrogen nuclei could be knocked out of nitrogen atoms by bombarding them with alpha particles. He had achieved the first artificial transmutation of one element into another, something alchemists had dreamed of for centuries. Neutrons were discovered by James Chadwick in 1932, when he identified an electrically neutral particle with nearly the same mass as the proton being emitted from beryllium targets struck by alpha particles. Chadwick won the Nobel Prize for this discovery just 3 years later. For a while, this seemed like it might be the bottom of the rabbit hole. Atoms are made of electrons, protons, and neutrons. Protons and neutrons are packed into the nucleus. Electrons orbit the nucleus at relatively enormous distances compared to the size of the nucleus itself. 3 particles, clean and simple. Maybe this was it. Maybe these 3 particles were truly fundamental. The real uncuttable building blocks that Democritus had imagined over 2,000 years earlier. But it was not the end. Not even close. Starting in the late 1940s and accelerating through the 50s and 60s, physicists began smashing protons and neutrons together at higher and higher energies in machines called particle accelerators. These machines used powerful electric and magnetic fields to push particles to enormous speeds before slamming them into targets or into each.
So I'm going to stop there. This is really a good video. I think everybody's got the link to it. They go on into quarks and smaller particles and into the standard model, which is about 13 particles. And as you get into the video, they start talking about with the standard model, which is the accepted model in physics, the one that everybody says is true. They start pointing out that even this model isn't true. They're discovering as they continue to divide things into smaller and smaller pieces and see what happens. And of course, they're using these colliders to do division now because you can no longer use a knife. This video is all about, now here we are, we think we really do understand everything. Uh-oh, look at this, look at this. We don't really understand this. We've been lying all along. We didn't really know we were lying, but it always seems to be the case that the more we study, the more questions we have, the new things that we didn't have before. This is physics. What's interesting about physics is it really does, if you look at the real history of physics and what the physicists do, it really is this Democritus' notion of dividing the world into smaller and smaller pieces to see if it gets simpler and simpler. And the rules by which the pieces operate tell you how everything in the world operates. That's really what physics is about. It has a property that at some point in the past, and it was around Descartes' time, physics started using equations. And equations are just a way of doing logic. It's really a kind of an interesting logic. What I'm going to do right now is show you all how it is that the human mind comes to understand physics. And so physicists are really understanding things the same way any other human being can understand things. They just have some very formalized ways of doing it. What I did in the chat, I put up probably the most famous formula in physics, E equal mc squared, which came from Einstein. That's the energy is equal to the mass times the speed of light squared. This is a paper, a very short, it's like a 1.5, 2-page paper that Einstein wrote in his glory years. He had a couple of years where he could do real work. One of the papers that he came up with, this E equal mc squared, and it was a deduction from his theory of relativity. In other words, he had come up with this idea of light is always a constant speed. What does that mean? No matter how fast you're traveling, light to you is always at the same speed, the speed of light. You would always measure it to be exactly the same speed. In this little 1.5, 2-page paper, he says there's an interesting thing that you can deduce from that, which is E equal mc squared. There are three things that you're talking about in computational cognitive science. Those are three subjects. You could talk about energy, you can talk about mass, and you can talk about light speed. What is in these equations that physicists love to use, you can take those three things and you can take any two of them as predicates on the subject you want to study. If what you want to know is what is energy, energy is mass times the speed of light squared. If you want to know what mass is, it's just energy divided by the speed of light squared. And if what you want to know is what's the speed of light, it's just energy that divided by the mass, where the result is this speed, this constant speed. You can pick a mass and you can compute the energy that will always give you the speed of light. And that's the amount of energy that mass has. So what most people have never done is they've never really understood what the physicists understand when they say this, because the physicists are incredibly imaginative And they say incredibly unbelievable things. What I did was I just took those three equations, from equal MC squared, and with just three subjects, and the predicates were the other two variables in the equation. The thing to realize is that c squared is a very big number. In terms of kilometers per second, it's 300,000 kilometers per second is light speed. And so 300,000, so squared, that's 300,000 times 300,000, or 90 billion kilometers per second. That's light speed, 90 billion kilometers per second. That's a big number. That's a long way to go in 1 second. 90 billion kilometers per second, where 1 unit of mass gives 90 billion units of energy. So 1 gram gives 90 billion, essentially ergs, or units of energy. Huge numbers. So in a very small mass, you get just giant amounts of energy if you can use all the energy that's in that mass. The last sort of thing I'll say there is associated with moving 1 kilometer per unit in 1 second, or 90 billion kilometers in 1 second. A unit in that system of mass will be capable of moving that mass 90 billion kilometers in 1 second. So if you've got 1 gram, the energy that will move that gram in 1 second is given by this equation. These are huge numbers. So when you all hear about things like it's going 1% of the speed of light or something, or an explosion is using some 1% of the mass that was in the uranium or whatever, or a very small percentage, you've got to realize these numbers are being multiplied times 90 billion. And you see how much energy is actually being created. And the energy is the ability to take a mass that's not moving and move it. So the energy is the amount of energy it takes to move them. The other thing to realize is they are actually realizing here that you can move 90 billion kilometers in 1 second if you can go the speed of light, which nothing really can, because you would require so much energy to actually move it. This is an example of how the physicists think, and they have to think seriously outside the box to come up with these crazy ideas that then revolutionize, prove the falsity of all the previous ideas and so forth that they had. What I'm doing in this particular paper is saying physicists are the best liars. They're amazing, but they're doing a very simple thing. They're really doing what Democritus did. They're dividing the world down until they get just a few things that you could talk about. And then they give you ways to talk about them using equations. So in equal MC squared, I can talk about energy, I can talk about mass, or I can talk about light in one equation that says equal MC squared. And so that's what they're doing, is they're doing exactly what the human brain does all the time, and all neural systems do all the time, which is they're finding ways to take any subject that you give them and do predicates around it. What the physicists are looking at is they're saying, let's try to find out the minimum number of subjects that can describe everything in reality, and the predicates that you can put around those subjects. And the way they do that is with these equations. They aren't doing anything that's really strange. They just don't talk about it. I doubt very many of y'all have heard physics described so cleanly as this guy just described it. So my argument is that physicists are the best liars. They're a great demonstration of how people live successfully lying in a good way. but they are always lying. This is what Descartes said, a good scientist always finds out that he was lying last week. My argument is that it is true that physicists are the best liars. Descartes really did say that. He did say that the only reality you can know is the reality you imagine. Because you will always find that whenever you discover one thing, yes, there are other questions that you have to ask. And you'll see this in a beautiful way in this video. What I said was, is it the truth? I said, yes. I don't know if this is actually the truth, because a lot of people will not call physicists liars, even though I think that they are. Some people will agree. I actually have other papers where I've had physicists in peer-reviewed papers have said that they are indeed liars, but in a good way. It's an interesting question to see if one could design a way to confirm that if it's actually true, but just suspected to be true. In other words, my answer is 70%. Is it the whole truth? I would argue that at one level, this is the whole truth. The physicists make the best liars. I really don't know a science that's as well focused on a form of simplification of reality that is as powerful as what physicists do. And that simplification is an enormous simplification. It's absolutely amazing, but it's incredibly imaginative. There's just no way you can see an electron. Excuse me. There are ways you can see an electron now that we know what an electron is, but you never really see the electron. You see the effects of it. One thing that most people don't know is if you take silver and you turn it into a mirror, so you polish the silver. Silver has this property that the electrons flow freely over the silver and through the silver. And so if you take silver and you polish it, it will become a perfect mirror. That mirror is in fact just a sheet of electrons. So when you're looking into a mirror, you're actually seeing pure electrons. This is crazy. The electrons are reflecting back the light. Remember the gold example the guy gave. But the light is, because the electrons are flat on that surface, the electrons are pushing directly back in the same direction that you're looking. So you see yourself in the mirror. A mirror is a way of looking at pure electrons that are not hot. They're whatever temperature they're at. Yeah.
I was going to say, I think any metal that has a current flowing through it, the surface of the metal is electrons.
So the surface is not. The interior is. The surface is with silver. You can polish it down, and it will. Yeah. But anything that reflects light, there'll be electrons that are flat on the surface. They're moving, but they're flat in the sense that they're covering the surface. But silver is the best reflector. It just is.
Yeah.
And it's because
almost got you in a line.
Yeah. Right. Is it nothing but the truth? I said again at one level, yes. What's the deceit? I don't think there is no real deceit in me saying that physicists are the best liars. It's a bit inventive, but I think that it's a really interesting case if you think of physicists as people who know that they're not telling the truth. Whenever they say we understand something, and they don't. They know they're wrong, but they persevere. And what they give to us is power over reality, which is great. But they are the best liars, and they really do get away with it. Is the deceit or truth intended? I think that I said, yes, the truth is intended. And I was shooting for the truth here from a point of view of the study of human lying, because it's really coming out of the inventiveness of the human brain to make sense in terms of being able to say things about things where you want to have the fewest things to talk about you could possibly have, and say the fewest things about them and that becomes physics. And you get that by Democritus, dividing things up and continuing to divide until you see the smallest things that can no longer be broken up into multiple things. What's the motivation behind the truth or lie? I think it's something to think about. It's interesting if you're thinking about Mendeleology to say who are the best liars in the world. It isn't Trump. It's physicists. It's not the con men. What's the social acceptability? By the way, I said best liars. I didn't say worst liars. What's the social acceptability of the truth or lie? I said it's completely acceptable. What label would improve it? I think it's interesting to think about whether lies by social groups like physicists are generally healthy lies. And that's actually an interesting thing to think about because groups of expertise, the expertise will invariably lie about things because they're regarded as the experts, but as experts, they usually realize they're not really experts. They may lie to you and say they are really experts. They really do understand everything when they know perfectly they don't. That's an interesting case. What I'd like to do is get the jurors to give me a 20 or 30-second summary of their take on this. Juror one.
Why I got picked juror one this week for this case, I'll never know. Because for one, me and math, y'all already know, don't get along. And two, you lost me on electrons, I think it was, or whatever. So you're the professional in this thing. So I was like, I trust him with what he says.
Oh, you realize that a mirror is just pure electrons?
No, I did not know that.
When you polish a mirror, you're actually smoothing the electrons to the surface.
Now, see, Bob, that's going to
So
mess
it's
with
a
me all day. I'm
perfectly
going to go in
flat-
here in the
it's a flat
bathroom and I'm going to
surface.
find the mirror.
It's a flat surface of electrons.
I'm going to go in here and I'm going to be polishing on this mirror. And whenever my roommate comes in, he's going to be like, "What are you doing?" I'm be like, "Bob says it's electrons."
It is. So it's crazy. But it's a back-plated mirror. The flat surface is the back of the mirror.
Okay.
But a front surface mirror, which is technically the best mirror, is a front surface mirror.
I know I'm going to have to let my roommate watch this after it's done today or whenever you get it published because he likes stuff like that. Yeah.
Yeah, Juror two.
I actually find this topic very interesting, not necessarily about the physicist and just I think the concept of it. Because now I'm wondering, what if more discovery was found based on what you just said, that mirrors are neurons and when you polish it? And what if that a new discovery with maybe new advanced technology discovered that was not really the case? Would that then make you, Mr. Robert, a liar? But
So I'll tell you where to look. A copper mirror. So why does the copper mirror have a color to it? Okay.
I don't know, but I'm just saying.
So a copper mirror is the same way. It's basically a surface of electron, but in copper, the electrons aren't as free to move as in the silver mirror, where they're almost perfectly free to move. And so it turns out you get the color because the electrons don't move as well on copper.
Okay,
so that's
like
a
Natasha
case
on this one. When it comes to numbers and science, it's not my base parts. What I thought about the case is that I wouldn't say, for me, I don't believe that physicists are the best liars or the worst liars at that. I feel like, okay, people that lie have to have the intent to mislead. And how I looked at it is that if they had an intention to deceive, then we can label them as that. But how I would explain it is just that they were using the evidence that was best available at that time. And obviously, if new research then comes up and improves the explanation, I wouldn't say it's an exposure of a lie. I would say maybe it's a refinement or just a new discovery of it. Unless the physicists are blatantly making sure that they are lying about these things. That's just about my take when it comes to this.
Yeah, in my world, it's because your brain thinks the way it thinks. It computes the way it computes in predications. It's inherent in any machine that computes in predication that it can never tell the truth perfectly. That's why we're stuck with this. What we see with science and so forth and so on is that, as it were, intuition engines. And that part of that is the reason is that we can't be pure logic, because often there's not enough data, not enough things you can directly perceive in a certain amount of time before you can, by logic, predict the next thing that's going to happen. If we were bound to pure logic and pure observation, then we would all probably never have made it to being human, because we would not have survived against animals that were able to intuit the truth, that just did that naturally as opposed to just naturally did logic. That sounds crazy, but it's true. This is all a property of how physicists are capable of thinking and why they can't know reality the way it might be if reality really does work with these sort of fixed mechanisms, which we really don't know. We don't know what they are, but what the science says is we'll never know because our brains work the way they work. Am I on juror 4 now?
Juror
Okay, 3.
So juror 3 is me. Yeah, hard to know where to begin, because it's an amusing joke. I like the joke. It's fun. But on the other hand, it's to single physicists out. Everybody, there's not a single person in the world who has a truth, fully established and understood truth. We're all liars to one degree or another.
That's why I call them the best liars. They are, if you look at bad liars versus good liars, okay, physicists are over in the best camp.
Yeah, yes, but are they? Because when physicists do lie, genuinely lie about their research, or lie that they're really hounded, they're really treated really quite severely.
But that's a minority of the physicists, I think.
Yeah, maybe. But it was interesting that the video you showed, is it Brian Cox? I mean, he was lying actually quite a lot about that. Lots of things, like, for example, this whole idea of the empty space in the atom is just not true. It's full of fields and orbitals, electron orbitals and things like that. The space is fully occupied. It's just in a different sort of level of description.
He actually does get into that later in that video. Yeah.
And it annoys me a little bit about Democritus, because he's a guy, Democritus is someone that I did actually study. And he didn't come up with the idea of let's subdivide the world. What he did is he observed things. He observed things like the young calves or kittens. They take nothing but their mother's milk, and yet they grow teeth and bones and hair and muscle and tissue. He reasoned from observation that there must be smaller particles, that matter is made up of smaller particles, which can then be absorbed and transmuted into lots of different arrangements. He wasn't just saying, let's subdivide, but of course, having come up with this idea, he then had to say, well, there should be a limit to the size of these particles, because the void was one of the things that Greeks got really interested in, and they used it to Zeno and all that, to the paradox of the arrow.
I think, go ahead.
So anyway, that was all to say, is that even Brian Cox, in his explanation of physics, was actually lying under your terms.
So some of his other YouTubes, I watched 1 or 2 other ones, he lies much worse on other topics. This one, he lied relatively less. But it's always, so if you watch this whole YouTube, you'll see that later he does get into the very things you were talking about. He does get there, but because of the way he's pressing forward his view, he says some things that are just wrong. Okay.
This is the feature of explanation. Any kind of explanation, whatever it is going to be a lie of some sort.
Yeah, that's right. That's exactly right. In fact, that's completely true. Juror 4.
Okay. Because of the dental procedure I had recently and half of hydrocodone I had to take about an hour ago, I'm a little bit discomforted and a little bit screwed up. But what I came out with all of this is that Physicists make a lot of guesses based on theories. So that's
So I think it's a little bit different. Physicists invent a lot of theories that are unbelievable if you think about them a little bit.
oh yeah.
And that's why I like this E equal MC square thing, is that once you realize what these numbers mean, you sit there and you go, well, this is impossible. 90, 90 billion kilometers in 1 second.
They just can say a lot of things because so many people don't know better, right?
Yeah, no, they say them because they're finding out that they're real, but it takes real inventiveness by a physicist to come up with these things. Takes them to these next steps of what are the smallest possible particles and so forth and so on. This thing called the standard model is the received view in physics. It's now coming apart. There are other particles that they're finding and so forth and so on. And there's a lot that's not accounted for and so forth and so on. So it's still got a long way to go. But it's amazing how far they got. But these people are incredibly creative. If you think about it, they're incredibly creative to sit down and say this. Imagine Einstein sitting there writing out something where he was perfectly aware that this meant 90 billion kilometers per second.
He just created that out of his head. You said,
Yeah, so he didn't. He actually read the actual measurements were from the guy who originally said light speed was the universal constant was Maxwell 50 years earlier, 40 years earlier. But he was making use of it. Where he was coming from was deducing from relativity, the equations for relativity that he'd come up with that assumed that light speed was always a constant speed, no matter how fast you're traveling. Remember, there's this notion of movement is energy, and light speed is movement. But light has no mass, so it doesn't take any energy except the energy that's in the light itself to move it. And light is pure energy. But there was no mass. If there were any mass, you would never be able to go light speed.
thank you.
Yeah. Okay. Am I at juror 6?
Not quite. You got to deal with juror 5 first.
Okay. Shoot. Okay.
Okay. So we have two physicists, physicist A and physicist B. Physicist A says there's no such thing as light waves. It's all just varying thicknesses of grape jelly. Now, physicist A knows that's not true, knows that's not fact, knows that all evidence is to the contrary, but physicist A insists that all light is merely varying thicknesses of grape jelly. Physicist B, on the other hand, teaches a college course and offers an analogy regarding the speed of light. Are both physicist A and physicist B liars?
That's how you view it, right?
No.
Okay.
My question to you is, using your rationale of the phrase of the term liar and the concept of lying, are they both liars?
The right answer is I am saying physicists are good liars in the sense that they're not trying to harm people. I think that any two physicists who are doing good physics by their perspective are liars, both of them.
The problem with this is you continue to use a term that has a common definition accepted by over 99% of humanity in order to embrace a concept that is not understood by over 99% of humanity. So you end up fostering a lack of communication and just massive confusion, because by your rationale, if I ever say anything that is not objective, demonstrable, eternal fact, I am a liar. And that's wrong. And it completely impedes any discussion of any topic. Full stop.
Yeah. My one defense is I can give you papers where physicists admitted that they were lying.
And if they say they were lying, as in like they are admitting that they intended a falsehood, correct?
Yeah, so the one paper that I'm remembering right now is the one
Sure.
where the physicist was illustrating a gravity as a ball on a rubber sheet.
Sure.
And he says, we're lying. It doesn't operate that way. Okay. But he says that we're teaching it. So when we're teaching it, we're lying.
And here's the issue with that. What that means is
And he says lie. He uses the word lie.
Simplification ever in any topic is a lie. But lying is an intentional deception.
So
You've got to
that's
step away from this idea.
So there's two types of intentional deception. One type is to help educate, okay, to be on the good side of intentional deception. So fiction, for example, is a bunch of intentional deceptions. When you write fiction, you're lying up the kazoo. But if good fiction is teaching people things, it's them learning about themselves and so forth and so on. But they are lying. If you ask a fiction liar, did that really happen? They'll say no.
And here's the
and then
issue.
they'll say, and then you'll
Go ahead.
say that was a lie, right? And you'll say yes, it was a lie, but you didn't get the real meaning. And the real meaning was true.
And here's the term you're conflating with lying.
So
Simplification.
I'm just looking at the use of the term.
And my point is you have an overbroad use of the term and it leads to confusion. So simplification is not lying. If I'm teaching a physics concept, all right, to 8th graders, I'm not going to be able to do derivative equations and calculations with them. I can't get to the absolute fact and the underpinnings of every proof, but I can give them analogies. That's not lying. It's simplification. But by this rationale, every professional everywhere that ever offers any kind of analogy or simplification is a liar using your vocabulary.
Yeah, I think the key element there is one of the questions is what's the deceit? What I would argue is that there can be lies for which there is no deceit.
Then you don't have a lie.
Not a lie, but a lot of people say that's like in the case of fiction, they don't know where the deceit started and where the deceit ended.
So let's take the book Dune by Frank Herbert. It's science fiction.
I was going to take mutiny on the back.
Bob, I just want to let you know I gotta go. I got an appointment I gotta get to.
Okay. 06.
Yes. Okay. So for me, I actually do agree with you that physicists are liars, because if they're going to explain to me something that they figured out and they can actually make it the best thing in the world, I'm going to believe them. Even if they add their lies and stuff like that, I will believe them because I'm not a physicist. Like with you, you can debate with Brian and Andrew because it's things that you guys understand. But with me, if you tell me something, I'm going to believe you. And then the thing that I found interesting about this case is about the mirror. So tomorrow morning when I'm doing my hair and my makeup, I'm going to say, I'm looking at protons now. I'm not looking at the mirror.
No.
Come on, yes. I'm going to look at electrons. Electrons is making me mad.
You can't see the protons. They're hidden.
But just the way they're reflecting back, I'm going to know it's protons this.
Electrons the electrons are reflecting the light back at you.
Yes. But it's very interesting. Thank you for teaching us every week something new.
07.
I said I don't know if it is entirely true. There are a lot being unsaid. For instance, what may seem to be true in today's theories can be redefined or replaced by tomorrow, making scientific progress the foundational mechanism. With that being said, science seeks to improve its models, not claim absolute final truth.
Okay. Sounds good. Juror 8.
Hi, so ultimately, I would like to say that going to answers and jurors, I would say that at the beginning, I was a bit skeptical by saying, sure, physicists are the best liars because they can describe the most unbelievable things with a straight face and make it sound completely logical, like they'll tell you time can slow down, space can bend, and all that jazz particles. But then ultimately, I would say that, oh, it's true because physics can sound real. Things will be relatively, time can slow down, and space can be quantum mechanics and all of that easy thing. Yeah.
Yeah. So you and I think, basically agree. But by the way, I think Brian has the strongest case against me. But behavioral psychologist, so I look at a lie as anything anybody calls a lie. Or if I say something, if I talk to a fiction author and I say, you're making all that stuff up, it's not true. They'll go, yeah. And I'll say, it's some fiction writers, you're deceiving people that as if these things were true. And they say, yes. And then you go, are you lying? And they'll go, yes, but that's fiction. Or they'll say, no, if you don't know how to read my fiction. But anyway, I got the last word. But Brian should be listened to. He has a perfectly valid position on this.
I'm going round and round with you. We're going to have fun. Let's keep going.
Okay, so we'll see y'all next week. Hopefully I'll have a less explosive one. But I really do believe that physicists make the best liars in the best sense of lie. And they do not make the worst liars in a bad sense of the worst. And so anyway, neither here nor there. So we'll see y'all next week.
Awesome. Be safe out there.